Okay, section 1.4 is about quadratic equations. Let a, b, and c be real numbers where a is not 0. A quadratic equation in the variable x is an equation of the form ax squared plus bx plus c. So we will first of all look at this very, very important but very, very simple property called the zero product property, which allows us to solve many, many quadratic equations and is actually the reason we can have the quadratic formula, which we're going to get to in a minute. And that property just says that if m times n is 0, then m is 0 or n is 0. In other words, when you multiply two numbers together and the product is 0, one of those things has got to be 0. There's no other way for it to happen. The only way to get 0 when you multiply is to multiply by 0. So this is very helpful when we want to solve an equation like this first equation right here. So we're trying to figure out x times 2x plus 1 is 15. How are we going to solve that? Well, we're going to use the zero product property. And what we're going to do is we're going to move everything to one side and leave 0 on the other side. And then we want to write everything on the left side of the equation as some kind of product so that we can use this property and say one of the things has to be 0. If you are multiplying two things together and you get 0, one of them's got to be 0. And that's how we're going to solve this equation. So we're going to go ahead and distribute the x and get 2x squared plus x minus 15 equals 0. Well, that left side does not look like a product, but we can make it look like a product if we factor it. A factor is something that is multiplied by something else. So we'll get a product if we factor this. So 2x and x, and then we have to figure out what two numbers multiply together to give us negative 15, and we'll help this add up to 1x. So if we put a 3 here and a 5 here, that's going to give us 15, and if we make this part positive and this part negative, that's going to give us a positive 1x for our middle term. So now that we have two things multiplied together to give us 0, we can say one of them's got to be 0. Either this is 0 or this is 0. And for that to be true, over here, x would have to be 5/2, and here x would have to be negative 3. So that's how we solve this equation. We found out what values will work in that equation. In other words, if you put in 5/2 to this equation, 5/2 times 2 times 5/2, which is 5, plus 1, which is 6. 5/2 times 6 is going to give you 30/2, which is 15. If you put in negative 3 into this equation, you get negative 3 times negative 6 plus 1, which is negative 5. Negative 3 times negative 5 is 15. So these are the two solutions to this quadratic equation, which are all the solutions it has. Two solutions for every quadratic equation. And we found them using the zero product property. If we didn't have that property, we wouldn't be able to solve it. And that's where so many of our quadratic equations get solved by that property. Okay, so this equation, 24x squared equals 8x, you might think, oh look, I can solve it. I'll divide both sides by 8x, and I'll get 3x equals 1. And then I'll get x equals 1/3. Well, guess what? A quadratic equation has two solutions, and you only got one of them. And the reason is because you divided both sides by x, and you don't even know what x is. If x is 0, you can't divide by it. So you can't do that. That is why we need to use the zero product property to solve this equation. So we will not do that. What we will do is subtract 8x on both sides. So we can have 24x squared minus 8x equals 0. And now we will factor. Now we can factor out the 8x and end up with 3x minus 1. And then we can use the zero product property. This multiplied by this is 0, so either this is 0 or this is 0. And now we get two solutions, x is 0 or x is 1/3. So there are two solutions to this equation, and one of them is 0, which means you did divide by 0 when you divided by x, and that's not okay. You can never do that. It will mess everything up. So don't ever do it. All right. So another property we sometimes use to solve quadratics, if we can, is the square root property. If we can get one side of the equation to be a perfect square, we can take the square root on both sides to solve for x. So in this first one, solve 3x squared equals 12, we can divide both sides by 3. 3 is not 0, and we get x squared equals 4. So now we just have this perfect square equals something else, and we can take the square root on both sides. And so square root of x squared is just x, and the square root of 4, this time we have to put plus or minus 2, because 2 squared is 4 and negative 2 squared is also 4. These are the two solutions to the quadratic equation. Over here we've got x squared plus 25 equals 0. We can subtract 25 on both sides and we will get this. And now we can take the square root on both sides to get x by itself. So x equals plus or minus the square root of negative 25. And so x is going to be plus or minus 5i. Solve x plus 7 quantity squared equals 8. We can take, you've already got a perfect square on one side, so you can take the square root on both sides, and you'll get x plus 7 equals plus or minus the square root of 8. So x is going to equal negative 7 plus or minus the square root of 8, and we have to simplify that square root. So we can take the 4 out, and it will be 2 square root of 2. And we want to write this, even though this is not a complex number, it does have a real part. It has a rational part and an irrational part. And it is really good notation to go ahead and write the rational part first and the irrational part second. Okay, completing the square is another way that we solve a quadratic, and it is actually how we derive the quadratic formula. So to complete the square, this is a list of steps to complete the square. I don't think reading the steps is going to help. I think going through the steps with a real problem will help. So if you want to take a screenshot of this so you can have it next to you when you do complete the square, you can, but we're not going to read it. You can read. All right, we're going to use it. So we have this quadratic, and we're going to solve it by completing the square. And the way we're going to do that, and the reason we're going to do that, is because we're going to use that square root theorem that square root property that we just talked about, where you have a perfect square on one side of the equation and a number on the other side of the equation, and take the square root on both sides. So that's why we want to complete the square. We want to get a perfect square on one side. And this process of completing the square is more useful. It's useful for other things besides just solving quadratics. In fact, we barely ever use it for solving quadratics because we have the quadratic formula. So learning to complete the square is not really for the purpose of solving quadratic equations. It's for something we'll do later where you'll have to know how to complete the square. Okay, so to complete the square, what do? You write your x term, your x squared term, and you write your x term, and then you put a blank, and then you move the constant to the other side of the equation, and you put another blank. You're looking for something to add to both sides of the equation that will make the left side a perfect square. Well, how do we know what to do? What does a perfect square look like? Okay, well, let's think about it. When you square a binomial, for example, x plus 8 squared, you would get x squared plus 16x plus 64. Just for example. Well, what is the arrangement here? All right, you can see that the middle term, which is 16, if you take half of that and square it, you get the third term. So take half and square it, and you get this, right? 16, half of that is 8. Square it, you get 64. So that is how we figure out what we want to add to both sides of this equation. We look at the middle term. In this case, it is negative 18. We take half of it and we square it. So half of 18, 18 over 2, squared is what we're looking for. So that's 9 squared is 81. So we want to add 81 to both sides of this equation. When we do that, we have created a perfect square binomial on the left side. How do we know what perfect square that is? Well, we want to get minus 18 for the middle term. And if you'll notice, if you look back over here, the perfect square binomial, that number that is second is half of that middle term. So half of 18 is 9, and this is going to be minus 9 because we want to get a negative middle term and a positive third term. So x squared minus 18x plus 81 is x minus 9 squared. If you don't believe me, you can multiply it out and find out that that is really what it is. So we have done what we were looking to do, and that is to create a perfect square on the left side of the equation. And now we will just add these numbers on the right side. And adding 81 to both sides of the equation is perfectly legal. You're allowed to do that with an equation. You can add anything that you want to both sides of the equation. Negative 5 plus 81 is going to be 76. And so now we can take the square root on both sides, and we'll get x minus 9 equals plus or minus the square root of 76. So x is equal to 9 plus or minus the square root of 76. And I believe 4 goes into 76, so we need to simplify that. So 9 plus or minus 2 times the square root of 19. 4 times 19 is 76, that's right. So this would be our solution. That is what, there are two solutions, 9 plus 2 square root of 19 and 9 minus 2 square root of 19. There are two solutions for every quadratic equation. So that is how you complete the square. So the quadratic formula for ax squared plus bx plus c equals 0, where a is not 0, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula. You do have to memorize it. You do have to know it by heart. It comes from completing the square on this generic quadratic equation, ax squared plus bx plus c equals 0. Basically, somebody said, I don't really like completing the square. I'm tired of doing it. So how can I just do it once and for all and never have to do it again? Well, this is what they did. They took this generic equation, they solved it using completing the square, and they got this formula so that now, whenever you have a quadratic equation and you know the leading coefficient, a, the coefficient of x squared, and you know the middle term coefficient on x, and you know the constant, c, if you just take those three numbers and plug them into the formula, you'll get your solutions without having to complete the square again, because this is completing the square. And we're just going to go back to our previous slide and erase all this and do this simple derivation of the quadratic formula just so you can see where it comes from. I guess if you forgot it and you knew how to complete the square, you could derive it yourself. And you may have done that already in Algebra 2, because I believe the Algebra 2 book, Saxon Algebra 2 book, does it. All right, so basically what we're saying is, suppose I have a generic quadratic equation, ax squared plus bx plus c equals 0, and I want to solve it. And the only way I can do that is by completing the square, because I don't know the quadratic formula. So you can't complete the square, and I didn't mention this, if you don't have a leading coefficient of 1. So before you can complete the square on this, you're going to have to divide the whole thing through by a. So divide everything by a, and you're going to end up with x squared plus b over a times x plus c over a equals 0. Okay, now you can complete the square. And remember, the way we do that is we say x squared plus b over a x plus something is equal to, and I'm moving the c over a to the other side, so negative c over a plus that same thing because we have to add it to both sides of the equation. Remember what that thing is. It is half of the middle term coefficient squared. So it is half times the middle coefficient, which is b over a, squared. And that is going to be b squared over 4a squared. So that is what I need to add to both sides of the equation. B squared over 4a squared, adding it to both sides. All right, since I did that, now the left side of this equation is a perfect square binomial. And that is going to be, remember, the middle term over 2 is what goes here. So x plus half the middle term, so b over 2a. And then the right side of the equation, I'm going to get a common denominator, so that's going to be, I'm going to have to multiply the top and the bottom of the first fraction by 4a, so negative 4ac over 4a squared plus b squared over 4a squared. And so that is, I'm just going to rewrite the right side of the equation, b squared minus 4ac over 4a squared. Okay, so now I will take the square root on both sides of this equation. So if I take the square root of x plus b over 2a squared, I'm going to get x plus b over 2a. And then the right side of the equation, as I said before, is b squared minus 4ac over 4a squared. I have to take the square root plus or minus the square root of that. And if I get x by itself now, I'll have x equals negative b over 2a plus or minus the square root of b squared minus 4ac on top, and at the bottom, the square root of 4a squared is 2a. So finally, I have the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the quadratic formula comes from completing the square once and for all for a generic quadratic equation. And remember, to know what a, b, and c are, you have to have this in order. The square term has to come first, the x term comes second, the constant comes last, and you have 0 on the right side of the equation. You can't just throw any old numbers in there for a, b, and c. This is the only way it's true, because this is how we did it. This is how we solved that equation by completing the square. And that is where the quadratic formula comes from, and you do have to memorize it. So, don't forget. So, if we want to solve this equation now, for example, using the quadratic formula, we just get it into the right form, multiply it out, 2x squared minus 6x plus 7 equals 0. And here's my a, here is my b, and here is my c. So I'm looking for negative b plus or minus the square root of b squared minus 4ac all over 2a. And now I can just fill those numbers in. So negative b is negative 6, so that's going to be positive 6, plus or minus the square root of b squared, negative 6 squared is 36, minus 4 times a is 2, c is 7, all over 2a, a is 2. So, going to have 6 plus or minus the square root of 36 minus 16 times 7. That is 6 plus or minus the square root of 76 all over 4. So that is 3/2 plus or minus, and 76 has a 4 in it, so we'll take that out. That'll be 2 square root of 19 over 4. So the final solutions are 3/2 plus or minus the square root of 19 over 4. And I think we already did that problem and we got the same answer. So that is how you use the quadratic formula. So the discriminant. The discriminant is b squared minus 4ac, which is the stuff that is under that radical in the quadratic formula. Whenever you have an equation, ax squared plus bx plus c equals 0, a quadratic equation like that, knowing the discriminant can help you find out how many solutions the equation has, because I've said every quadratic equation has 2 solutions. Actually, that wasn't true. It can have only one. It can have one, it can have 2 real solutions, or it can have 2 complex solutions. Those are the only 3 possibilities. And knowing the discriminant, b squared minus 4ac, for any equation will tell you how many solutions it has. The reason is because if b squared minus 4ac comes out to be 0, then that part of the solution is gone, and all you have is negative b over 2a. So if the discriminant for an equation, a quadratic equation, is 0, it tells you that there's only one solution, and that's going to be a real number. If the discriminant is positive, b squared minus 4ac is greater than 0, like in this second situation here, if you have an equation, a quadratic equation, and you're trying to figure out how many solutions it has, and you just try and find out what b squared minus 4ac is, and it comes out to be a positive number, then there will be 2 real solutions, because that means the number under the radical, b squared minus 4ac, is positive, and that is a real number. So you'd have 2 real solutions, because you'd have negative b over 2a plus or minus that number over 2a, and that would be a real number. If b squared minus 4ac is negative, that is, if it's less than 0, then you're going to end up with 2 complex solutions, because the value under the radical is going to be negative, meaning that is an imaginary part. So you're going to have negative b plus or minus something I over 2a, and therefore you're going to have 2 complex solutions. So it's not real obvious right now why you would only care about how many solutions there are instead of just finding the solutions, but there is a reason for that, and later on you will find that out. So here, if you just want to figure out how many solutions there are to each of these equations, you can just find the discriminant. Remember, the discriminant is b squared minus 4ac. So if I look at this first quadratic here, a is 1, b is negative 10, and c is 25. Let's see what b squared minus 4ac is. Well, b squared is 100, minus 4a is 1, c is 25. And so that is 100 minus 100, which is 0. The discriminant is 0, so there is just one solution. That equation has one solution, and the reason is because it's a perfect square binomial. But no need to go into that right now. X squared minus 9, how many solutions does that have? Well, let's see. B squared minus 4ac. B in this equation is 0. There is no b, because x squared has a coefficient of 1, and then you've got a constant, negative 9, but you don't have an x term, so there's no b. So b is 0. Minus 4a is 1, c is negative 9, and so you end up with negative 4 times negative 9 is 36. So since the discriminant is positive, that means that this equation has 2 solutions. And that's obvious. X squared equals 9 would give you 2 solutions of plus or minus 3. But that's not the point I'm trying to make right now. The point is you can find out how many solutions an equation has without actually solving it. All right, a quadratic equation anyway. So let's look at this one. B squared minus 4ac for this. B is 6, a is 1, 2 is c, so b squared is 36. 4a is 1, c is 2. 36 minus 8 is going to be 28. And so that is greater than 0. Therefore, this equation has 2 solutions, 2 real solutions. I'm sorry, I should have said that over here. 2 real solutions. 2 real solutions. Okay, over here we've got x squared plus 3x plus 5. Let's see what its discriminant is. B squared is 9. 4a is 1. C is 5. So 9 minus 20 is negative 11. So that's less than 0. So you're going to have 2 complex solutions, because the discriminant is less than 0, which means there's going to be a negative number under the radical, and therefore you're going to have an I. So two complex solutions if the discriminant is less than 0. Okay, lastly, we have a couple of problems where we are going to solve for a specified variable. These are problems that have mostly variables in them, and we're just going to isolate one of those variables. So this first equation is solve for r in the equation v equals 1/3 pi r squared h, where r is greater than 0. That is the volume of a cone, actually, and the reason they're telling us that r is greater than 0 is because during this problem we're going to have to take the square root of r squared, and they want us to know there's only one possibility because r is positive. So, and also that it's not going to be, we won't have to use plus or minus when we do that. So to get r by itself, we first have to get r squared by itself, so we're going to multiply both sides by 3, divide both sides by pi, and divide both sides by h to get r squared all by itself. So when we multiply by 3, we're going to have 3v on the left, and then we're going to have pi in the denominator and h in the denominator because we're dividing by those things. And all that we'll have left on the right side is r squared. Now we're going to take the square root on both sides. We don't have to put plus or minus because they told us that r is positive. 3v over pi h equals r. And now we have to rationalize the denominator because this is 3 square root of 3v over the square root of pi h. So we have to multiply top and bottom by pi h, square root of pi h, sorry. And that is going to be the square root of 3v pi h over pi h. And that is r. Okay, this next one says solve for t. And so we have mt squared plus nt equals z. So we want to get t by itself, but no matter what we do, we're not going to be able to get t by itself because this is quadratic. So what we're going to have to do is get everything on one side and use the quadratic formula. So we're going to subtract z on both sides, and now we can use the quadratic formula. M is our a, n is our b, negative z is our c. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative n plus or minus the square root of n squared plus 4mz all over 2m.